we're going to go ahead and evaluate this limit using the lowest common denominator technique. So the idea here is we're going to look at each fraction, complex fraction specifically, and use that to make a lowest common denominator. So we're going to look in this fraction here. We're going to say in the denominator we have an x. Now in the next fraction in its denominator we have a 6. So we don't already have a 6 in our list. So we're going to go ahead and put a 6 there. Now you could also think it as 2 times 3. Okay. And then there are no fractions, no complex fractions in the denominator, so there's nothing left to add in our list. So our LCD, you could then simplify to write as 6x. So now what we're going to do is we're going to clear our fractions in our numerator and our denominator by multiplying by 6x. And we're going to go ahead and distribute this through, resulting in the limit as x approaches 6 of 6x divided by x minus 6x divided by 6 over 6x times, and actually I'm going to leave the denominator factored to make my life a little better, because the whole goal is to factor and simplify anyway. So we're going to go ahead and do that and clean this all up. Now for the division, the x divides with the x, the 6 divides with the 6, as with the limit as x approaches 6 of 6 minus x over 6x times x minus 6. And now we can see no more complex fractions, right? The LCD, using the LCD method, has done that for us. Now, we could have done this from the very first step, where if we substituted in x approaches 6, we probably should have done that in the very first step. I apologize. I just got so excited. I wanted to jump right into the calculus. I forgot to start with the very basics. When we sub in 6, we're going to end up with 1/6 minus 1/6 over 6 minus 6, which results in 0 over 0. So it's of indeterminate form. Let's see if that has changed. Let's go back down here to our new version. When I sub in the 6 now, I'm going to get 6 minus 6 over 6 times 6 times 6 minus 6. And that's a whole bunch of 6's in the denominator, which I'm not a huge fan of. We want those to go away, but the moral of the story is we still have 0 over 0. So it's still indeterminate form. We need the factoring and division to occur. Now, sometimes we get really excited. We're like, hey, we have a 6 minus x and an x minus 6. Aren't those the same things? No. They need to be exact. But one of the nice things when you recognize that it's the same factor, just with the signs switched, all we need to do is factor out a lowest common multiple. We can factor out a -1. And that turns into something really nice. So I'm going to go ahead and factor in -1 from my numerator. And what that's going to end up doing is we say it's just going to end up flipping our signs. And I'll switch the order to represent that. But so you'll see, if I were to take this -1 and distribute it back through, it would be -1 times x, which would be -x, and -1 times -6, which would be +6. So the nice thing about this, when you factor out the -1, the sign switch, so we switch the order as well to make it in a descending function. And now the x minus 6 and the x minus 6 divides. And now we're able to substitute in. I'll do it in one more line. I'll show it written out. But what are we left with after that division? Well, that'd be -1 over 6x. And now, when I substitute in my 6, I'm left with -1 over 36. And you can see we're now able to evaluate that limit algebraically by eliminating the complex fractions.